Okay, guys, this is Miss Richards. And this is the video for Monday, October 16th. And what I want to do before we go into the lesson, I want to make sure we understand the homework from Friday, October 13th. We had 2 pages to get through. Some of these examples we did in class on these practice problems. I don't think you really should have had issues with 1 through 7. You didn't have to simplify anything. Number 1 is negative square root 6. Number 2 is square root 7. Now you could have put a 1 in front of that. On number 2, you could have also, for number 1, you could have put it as negative 1 square root 6, okay? 3 is negative 22 on the square root of 21. Number 4 is the square root of 15. Again, you could have had a 1 in front of it or left it just like this. Number 5, you should have gotten 2 square root 7. Number 6, you should have gotten negative 7 square root 17. Number 7, negative 21 square root 11. Number 8, 7 square root 3. Number 9, negative 2 square root 6. Number 10, 11 square root 6. Number 11, square root 3, or again, you could have put 1 square root 3. Number 12, you should have gotten 0. When you simplify the square root of 27, you end up getting 3 square root 3. So that's why number 12 is 0. 13, you should have gotten 9 square root 2. 14 is 0. 15, negative 7 square root 5. 16, 4 square root 5. 17, 7 square root 2. Number 18, negative 3 square root 2 minus 2 square root 6. Or guys, if you had it as negative 2 square root 6 minus 3 square root 2, that also works. It's the same thing. Number 19, you should have gotten 9 square root 2 plus 12 square root 3. Again, you can switch the order and you can have it as 12 square root 3 plus 9 square root 2. Number 20, you should have gotten negative 4 square root 5 minus the square root of 6. Again, you can switch the order, and for the square root of 6, if you put a 1 in front of it, that's fine. Number 21, negative 9 square root 2 plus 6 square root 5. Again, you can switch them around. 22, negative 6 square root 3 minus 2 square root 2. 23, negative 6 square root 5 plus 6 square root 2. Number 24, 12 square root 2 minus 4 square root 3. Number 25, negative 3 square root 5 minus 2 square root 6. And finally, number 26, you should have gotten 2 square root 5. Again, there is a copy of this video. It will be uploaded to Canvas, to your Canvas page. If you didn't get some of these and you want to go back and review, the video will be there. Okay, so if you need to pause the video at any point, just do that. So what I want to do now is I want to look at our notes for today. Today we are looking at multiplying radicals. Last week we did, we did simplifying radicals and we did adding radicals. But today we're going to look at multiplying radicals. Okay, so your notes should look like this, just like this. Number 1 here, you're going to say, when you're multiplying radicals, the first thing you want to do is multiply the coefficients if they have them. So let's write this in, multiply the coefficients. I'll try to get this straight, sorry. Okay, that's your first step. Step 2, multiply the numbers inside the radicals. Okay. In another room. Okay. Number 3, simplify. Okay. We have this example. We have square root of 6 times the square root of 9. Let me just move this so you can see. Sorry, guys. And so this becomes 6 times 9, all underneath the radical. 6 times 9 is 54. And we can reduce this as, when you simplify it, it goes down to 3 square root 6. There's a couple ways to do this. You can get it down to the prime numbers. That's what they've done here. Or, I mean, think about this when you're multiplying these. What is the square root of 9? The square root of 9 is just 3. So we multiply 3 times the square root of 6. And that's the same thing we get down here. Okay. Basically for these, if you have a number outside the radical, it stays on the outside. So outside stays with outside, inside stays with inside. So on, let me get some markers. On this next example, we have 3 square root 2 times 5 square root 6. So the 3 and the 5 are on the outside, and that gives you 15. Okay. On the inside, you're going to have 2 times 6. And again, that stays on the inside. 2 times 6 is 12. But, you know, you can rewrite 12 as the square root of 4 times 3. The square root of 4 is just 2. So that's where this 2 on the outside came from. And then 15 times 2 is 30. You're still left with square root 3. So we call it 30 square root 3. Okay, I'll give you a minute to get all that. And then we'll go over here to the right, where we have a few more examples to look at. So this one says a square root x times b square root y. So a and b are some numbers, and that is ab is going to be the product of a and b, and it stays outside the radical. Okay. And again, the numbers on the inside, x and y, stay on the inside. So outside stays with outside, inside stays with inside. Okay, so the square root of 2 times the square root of 5 is just the square root of 10. Okay. So we're going to combine into the radical. That's what this says. And then simplify what's inside. Square root 10 does not simplify any further. So that one was easy. We're done with that. Now on this next example, it says 2 square root 5 times 7 square root 3. We're right here. So the 2 and the 7 are on the outside. So we're going to have 2 times 7 on the outside. And the 5 and the 3 are on the inside. So they're going to stay on the inside. So 2 times 7 on the outside, square root 5, square root 3 on the inside. So 2 times 7 is going to give you 14. 5 times 3 is 15. So that's square root 15. So 14 square root 15. And then this says multiply the regular numbers together and multiply the radicals together. So again, inside with inside, outside with outside. Okay, so let's try it out. I want you guys to pause the video. I don't know, maybe a minute or two. See what you can do on these 4 problems, and then unpause the video. Okay, you should have paused the video. So let's go over these. Let's look at number 1. Number 1 says 3 square root 12 times the square root of 6. Okay, so technically we have a 1 right here. What is 3 times 1? It's just 3. That's on the outside. On the inside, we have 12 times 6. Well, what is, oh, sorry. Move it down. There we go. What is 12 times 6? It's 72. So what we're left with is 3 times the square root of 72. Again, when you are simplifying, the best thing to do is make a list of your perfect squares. We've got 4, 9, 16, 25. I'm going to stop there. Well, I'll stop at 49. Okay, let's see which one is the biggest number that fits into 72. So get your calculator, and then that's going to be, start dividing. 72 divided by 4. Okay, let's see if we can get any higher. 72 divided by 9. Great. Let's see if we can go higher. 72 divided by 16. Nope. 72 divided by 25. We know that's not going to work. So let's do 36. Look, 72 divided by 36 is 2. And you know that the square root of 36 is just 6. So we're going to say 3 times the square root of 36 times 2. We're just rewriting the number 72. The square root of 36 is 6. So this is 3 times 6, square root 2. Okay, so that gives us what? 18 square root 2. Yep. Okay. On number 3, what happens here? Square root 6 times the square root of 6. Well, there's no coefficients here, so everything stays on the inside. So what is 6 times 6? That's 36. So you get square root 36. And what is the square root of 36? Oh, that's just 6. Okay. So on this side, you should have gotten 18 square root 2 and then 6. Okay. Number 2. Sorry, I went in the wrong order, guys. I went 1 and 3. It's all right. Not a big deal. Okay. I'm going to see my list over here. Okay. Can't see the list. Let's scoot it over just a little bit. Okay. On number 2, there's no coefficients. You just have square root 5, square root 10. So we're going to keep everything under the radical. That's square root 50. Now, look at your list. Can you see that 25 fits really well, like really nicely into 50? So we're going to rewrite 50 as 25 times 2. Give everything its own radical. We don't always have room for this step, but it's a good one to include when you have room. Square root of 25 is 5, and then that's square root 2. Okay, and number 4. Okay, so number 4 on the outside, let's see if we can still see my numbers. I'll just make a new list. 4, 9, 16, 25, 36, 49. Okay, on the outside, you technically have a 1 here, so 1 times -4 is just -4. On the inside, 5 times 20 is going to be what? 100? And then, guys, what is the square root of 100? It is 10. So you end up getting -4 times 10, which is just -40. Okay, so go ahead, make sure you've got all that. And now we're going to do some more examples. Okay, so this is about word problems. All right, steps for solving basic word problems involving radical equations. And we'll do more word problems later on throughout the week. Okay, so step 1, what you want to do is plug in any known values. You want to plug in any known values. Okay. Step 2, you want to simplify/solve to find the unknown value. If the unknown value is inside the radical, then undo the radical by raising each side of the equation to the same power as the radical index. What that means, so if you have a radical, if you have the square root of 6, to undo that, you just square it. So the square root of 6 times the square root of 6 is the square root of 36, which is just 6. Okay, so when you do that, you end up getting whatever this number is under the radical, okay? So some examples. This says, hold on. Get that straight for you. A pine cone falls from a branch that is 180 feet off the ground. The velocity of a free-falling object is given by the equation v equals the square root of 2 times g times h, where v represents the velocity in feet per second, h is the height in feet, and g is 32 feet per second. What is the velocity of the falling pine cone? Step 1, you want to plug in the known g and h values. Okay, so what was g? G is 32 feet per second. Okay, and then h, which is our height, is 180. Okay, so we're going to say v equals the square root of 2 times 32, which is our g, times 180, which is our h. Okay. And this doesn't simplify nicely. You end up getting a decimal. So v equals, I'm going to rewrite this 2 times 32 times 180. And when you multiply all of those together, that gives you, when you multiply 2 times 32 times 180, you get 11,520. And when you simplify that, and guys, generally for word problems, it's wanting you to give them an exact answer. And we use radicals to kind of simplify decimals, so we don't have to write out long decimals. That's why we write it in radical form. But in this situation, you're going to have to provide the decimal. So what you would do in this situation, just get your calculator. You're going to type out the square root. Sorry. The square root of this long number, 11,520. And it's going to give you a decimal. It's not even going to give you a radical. So we're going to round to 2 decimal places. So this is going to be 107.33. And then that round, we're going to do to the nearest whole number. So that would just be 107 feet per second. Oh, you can't even see. Okay, 107 feet per second. Okay. And then we have one more example down here, and I'm going to do some practice problems with you. Okay. Look at this down here. Says if the volume V of a cube with a side length S is given by the following equation, V equals S cubed, what is the side length of a Rubik's Cube that has volume 24 cubic units? Step 1, plug in the known volume for V. Well, the volume V is 24. So step 1, 24 is where the S cubed came from. So we're plugging in for V, and V is right here. We're just plugging in a 24 here. Okay. Step 2, solve for the unknown side length. Okay, so what you have to do in this situation, you have to, I'm just going to rewrite this, 24 equals S cubed. To undo the cubing, let me move this down. To undo the cubing S, take the cube root of both sides of the equation. So what that means is the cube root looks like this. And we're going to do that for both sides. We're going to do it for the 24 and for the S cubed. Okay, so when you do that, type that in. So the cube root, and on your calculator, let me show you. If you do second and then go down to this button, it's going to show up like that. Right here where it says ANS, you're going to type the number 3. Okay, and then you want the cube root of 24, which is 2.88. Okay, so if we round to the nearest whole number, and that was 2.88, that's going to be around 3. The side length is approximately 3 cubic units, right? Or 3, we're just going to simplify it and just say 3 units. Okay. So go ahead and turn the page. We're going to do some examples together. All right, we did examples 1 through 5. We did stuff like that. We did not do examples where we have variables. So let's pick a few. And whatever I don't get to is your homework. Okay, so number 7, we have the square root of 15 n squared times the square root of 10 n cubed. So we've got 15 times 10, which is 150. So that's going to be the square root of 150 n squared times n cubed is just n to the 5th. So we get 150 n to the 5th. All right, and think about 150. Think about your perfect squares. 25 is going to fit into 150 6 times. Okay, so I'm just going to make this a long radical. You'll see why. So that's 25 times 6. Okay. And then I'm going to expand this. So we have n times n times n times n times n. We have 5 of them, right? What you want to do is circle the pairs. And the pairs combine as 1 and they come outside the radical. So we know the square root of 25 is 5. We had one n come out, we had a second n come out, so that's times n times n. And then on the n side, you're left with a 6 and an n. So your final answer here is 5n squared square root 6n. Okay, and just FYI, the calculator will not do variables for you. Just FYI on that one. Okay, let's do number 11. Okay, when you have this, you're going to have to distribute whatever's on the outside. So square root of 3 times 5. 5 doesn't have a radical, so we're just going to say that is going to be 5 square root 3. It's kind of like saying if you had something like this. 5 times x is just 5x. You just combine them, right? We just combine these, and you want to put the radical last. So square root 3, 5 comes before the square root of 3. And then plus, that's the sign we have. Square root 3 times square root 3 is the square root of 9, because 3 times 3 is 9. So this is just 5 square root 3 plus 3, and you are done. Okay, so that's how those work. I wanted to show you a couple of these. Okay, so let's turn the page. I'm going to do some more on the back. Yeah, I want to do a few of these, just so you kind of have an idea of what to expect. All right, number 15. Again, you're going to have to distribute. On the outside, we've got a -2 and a -3. That combines to give us -6. On the inside, we've got 15 times the square root 3. Hold on just a minute. I'm going to make this. These are kind of hard to see. So let's get this. Yeah, that's better. So we have -6. And then 15 times 3 should be what? 45. Yep. And then, so we distributed to this one. Now we have to distribute to 3 square root 5. So on the outside, you've got -2 and 3. So -2 times 3 is going to be a -6 again. And then on the inside, you have 15 times 5, which that's going to give you 75. Okay, and I'm actually going to switch to a piece of paper as I want to have room. So we ended up getting what? -6. This is number 15. We ended up getting -6 square root 45 minus 6 square root 75. All right, and now we just have to simplify. So the square root of 45 can be rewritten as the square root of 9 times 5. And then this step, let's just go ahead and give everything its own radical that's underneath. The square root of 9 is 3, so we get -6 times 3 times the square root of 5. That's going to give us -18 square root 5. Okay. And then on this one, we have -6. We can rewrite 75. It's 25 times 3. Okay, so we get, give everything its own radical. It's going to be square root 25. Didn't mean to do that, times the square root of 3. Square root of 25 is just 5, so we have -6 times 5 times the square root of 3. And then what is -6 times 5? That's going to be -30. So that's going to give us -30 square root 3. But can we combine anything? The answer here would be no, because they don't match. So the final answer for this one, you should get what? -18 square root 5 minus 30 square root 3. Okay. That's how you do those, redistribute. And some of them have variables. The next kind of problem I wanted to do, let's go ahead and do a hard one. At the bottom here, we've got, like it looks like 21 through 28. You're distributing twice. So I'm going to do 25. This one looks like it's got a lot going on, so I think it's a good example to go through. So 25. We've got 5 times 2, the square root of 2x, plus the square root of 5. And then we're going to multiply that times -4 square root 2x plus the square root of 5x. Okay, so basically, I'm going to take this and we're going to distribute it here, and we're going to distribute it here. Okay, so let's do that part together. On the outside, we've got 5 times -4, which is just -20. Okay, on the inside, for the first one, we've got 2x times 2x. Well, 2 times 2 is 4. X times x is x squared. Okay, and then the next one, you don't have a coefficient. It's technically a 1. 5 times 1 is just 5. Square root 2x times square root 5x is just the square root of 10x squared. Okay, so we have successfully distributed that. Now we have to distribute this, okay? And we have to distribute it to both those, okay? So we have 1 square root 5 times -4 square root 2x. 1 times -4 is -4. Square root 5 times square root 2x going to be the square root of 10x. And then square root 5 times square root 5x. You know, you can technically put a 1 on the outside. You don't have to. I'm not going to. 5 times 5 is 25, and then you still have that x underneath. Okay. So I've shown you where those came from. Now let's combine, simplify, do all that good stuff. So yeah, we can simplify this. -20 square root 4x squared. Well, just like a side note, the square root of x squared is x. The square root of x to the 4th is x squared. You just take whatever, if it's an even number, if the exponent is an even number, just divide it by 2, and that gives you your square root. Okay, so the square root of x squared, 2 divided by 2 is 1. Okay, so again, if it's a variable and it's got an exponent, and that exponent is an even number, it is a perfect square, and it can come outside the radical. So we've got -20, square root of 4 is 2, square root of x squared is just x. So we have what, -40x. 10, there is no perfect square that fits in a 10, but the square root of x squared is x. So this is going to be 5x on the square root of 10. Okay. And then here, this just comes down. We can't simplify that one. -4 square root 10x. And then here, the square root of 25 is 5. So this becomes plus 5 square root x. Okay, take a good look at that. Now, is there anything we can combine? I don't see anything. So this is your final answer. -40x plus 5x square root 10 minus 4 square root 10x plus 5 square root x. Okay, so for the rest of class, you need to work on the rest of these. These 2 pages, it's 1 through 28, And I've given you 4 problems, as examples. I've taken out, so I've instead of 28 that you have to do on your own, you have to do 24, and you have a lot of class time to do this. So go ahead, get started on this, and then realize that this video will be uploaded to Canvas if you need to go back and if you need to see anything, okay? Have a great day.